So for problem number 11, we have, let's go ahead and get rid of parentheses first. And we're going to take 2 to the negative 1 up on top. A to the 3. So by the way, backing up, we always want to, when we have a power to a power, we want to multiply. So any number, when we don't see an exponent, that exponent is automatically a 1. It's understood, implied that it's a 1. 2 just sitting there by itself is the same as 2 to the first power. Helps us visualize when we have a power to a power, we multiply. 1 times negative 1 is negative 1. Then we have a to the third to the negative 1, and that makes a to the 3 times negative 1, which is negative 3. That's up on top. Now on the bottom, we have a to the third, and we have b to the third. Now we're going to move any exponents that are negative. We're going to move them, move that entire term or factor, if you want to say it like that. We're going to take this factor, 2 to the negative 1, and we're going to move it to the bottom, the denominator, and make that 2 to the positive 1. We're going to take a to the negative 3 on top, and we're going to move it down to the bottom, make it a to the third. We're going to keep the a to the third and the b to the third on the bottom, and then what do we do at the top? Well, all of these is still a 1 times that, so we just leave a 1 up there. There's no other terms besides 1. We can't just leave it alone, can't just put 0. And then we just rewrite and combine the a cubed with the a cubed. 2 to the first power is 2. A to the third times a to the third. 3 plus 3 is 6, and we have b to the third power. All right, we're almost there. So up on top on number 12, we have getting rid of parentheses, a to the third, b to the third, over a to the negative 1. I could have moved that just now. But we have a negative exponent on the bottom, and we're going to move that negative exponent to the top, make it positive. So that gives us a to the first times a to the third times b to the third on top over a c. That exponent's positive. And then we're going to go ahead and combine. A to the 1 plus 3 is 4 times b cubed all over c. And that gives us our first 12 problems. Now, if you remember, the problem number 13 is not going to be on the quiz, but I'm going to go ahead and graph it anyway. 1/2 to the x power. Key features are, where do we have our y-intercept? So if you remember, the y-intercept, let x equal 0. Anything to the 0 is 1. So there's our y-intercept. We could replace x with negative 1 and then do the math. You flip it over, make it 2 over 1 to the 2. So negative 1, we get 2. A negative 2, 1/2 to the negative 2 is 2 to the positive 2, which is 4. And so we're just going to get some ordered pairs and plot those ordered pairs so we can remember the pattern of the dots, create our graph. So if you ever forget what the graph looks like, you can just plot some points. 1/2 to the 1 is 1/2. And then 1/2 to the 2 is 1 over 4. 1 over 4. So you could see if you plugged in 3, you get 1/3 or 1/8, and so on. So as x gets bigger, the y coordinates get closer and closer to 0, and it's really hard to show that, trying to get there without hitting the x-axis. And then as x gets more negative, as x moves to the left, the y coordinates get higher and higher. Now with exponential functions, we have asymptotes, and the asymptote on this particular function is the line y equals 0. So asymptote y equals 0. Our y-intercept, we already talked about that, 0, 1. Now from the graph, we can see the range is all real numbers greater than 0. So we say y has to be greater than 0, less than infinity. So basically y goes from 0 to infinity. And then x can be anything. X can be, has to be greater than negative infinity, or greater than negative infinity all the way to positive infinity, and there are no breaks in between. So the domain is going to be always all real numbers minus any exceptions. In other words, you can raise 1/2 to any power. So if you can raise 1/2 to any power, you're allowed to plug in any power for x. You're allowed to plug in any real number, and that's why the domain is all real numbers. And we can see the y coordinates are getting smaller, so this is exponential decay.